Welcome to our video on deployment strategies. Whether you're launching a new app or updating an existing one, choosing the right deployment strategy is crucial for success. In this video, we'll explore various strategies like Canary releases, blue-green deployments, and A/B testing. We'll discuss the benefits and challenges of each method and help you determine which approach is best suited for your business needs. Get ready to dive into the world of deployment strategies and learn how to deliver software updates smoothly and efficiently. A recreate deployment is a straightforward method for updating software. Here's how it works. Imagine your app is a store. In a recreate deployment, you close the store, remove all the old items, the old app version, and restock it with new items, the new version. The store is temporarily closed to customers during this process. Similarly, in a recreate deployment, the current application version is stopped, the new version is deployed, and then the application is restarted. This method ensures the new version is fully in place, but results in some downtime during the switch over. There are a few stages of recreate deployment strategy. Prepare the new version. Ensure the new version of the application is fully tested and ready for deployment. Notify users. Inform users about the planned downtime if necessary. Shut down the application. Stop the current version of the application to take it offline. Deploy the new version. Replace the old version with the new version in the environment. Start the application. Bring the application back online with the new version running. Verify deployment. Test the new version to ensure it's functioning correctly. Key benefits of recreate deployment. Simplicity. Only one version of the application is managed at a time, avoiding issues with backward compatibility. Considerations. Downtime. This approach involves downtime during the update, making it unsuitable for mission-critical applications with high availability requirements. For such applications, other deployment strategies might be preferable. A blue-green deployment is a strategy used to reduce downtime and minimize risk when deploying new versions of software. Here's a simple explanation. Imagine you have two identical environments. One is blue and the other is green. The blue environment is the current live version of your application that users are interacting with. When you're ready to release a new version, you deploy it to the green environment. Once you're confident that the new version is working correctly in the green environment, you switch the traffic from the blue environment to the green one. This switch is usually seamless, so users don't notice any downtime. If something goes wrong, you can quickly switch back to the blue environment, ensuring that users always have access to a working version of your application. Here are the steps for a blue-green deployment. Prepare the green environment. Set up an environment identical to the current live environment, blue, called the green environment. Deploy the new version. Deploy the new version of your application to the green environment. Test and verify. Conduct thorough testing in the green environment to ensure everything works correctly. Switch traffic. Once verified, redirect user traffic from the blue environment to the green environment, making the new version live. Monitor and rollback if needed. Monitor the application for any issues. If problems arise, you can quickly switch back to the blue environment. Zero downtime. Enables quick cutover with no downtime during deployment. Instant rollback. Allows immediate rollback by redirecting traffic back to the blue environment if issues arise, minimizing downtime impact. Environment separation. Isolates the green environment from the blue, reducing deployment risks by preventing interference with existing resources. Considerations, cost and overhead. Maintaining duplicate environments increases costs and operational complexity. Backward compatibility. Ensure both versions can use the same data schema and format for smooth rollbacks. Cutover process. Allow for connection draining to gracefully terminate or complete existing transactions before decommissioning the old version. A Canary release is a deployment strategy where new features or updates are gradually introduced to a small subset of users or instances. This method helps identify and address issues in a controlled environment before a full-scale release. For example, if you're managing a website, you might initially roll out a new feature to a small group of users or instances. If any problems arise, they can be resolved without affecting the entire user base. If everything works well, the update is then gradually rolled out to more users, ensuring a smoother and safer deployment. In a Canary release, software deployment happens in stages, where version 1 is the current stable version and version 2 is the new release. Here's how it works. Initial state. Stable version is running for all users. It's fully tested and considered reliable. During update. Initially, V2 is released to a small group of users, Canary group, or instances while the majority continue using V1. This stage is to test the new features and identify any issues in a real-world environment. Final state. Once V2 is confirmed to be stable and reliable, it replaces V1 for all users. Key benefits of Canary testing. Live testing allows testing on live traffic for real-world feedback. Fast rollback, quickly revert to the previous version if issues arise. Zero downtime, routes traffic without interruption. Considerations. Slow rollout, requires careful monitoring, delaying full deployment. Observability, needs robust monitoring systems. Compatibility, risks with backward compatibility and session persistence during multiple version deployments. An A/B deployment is a strategy used to test changes in software by running two versions, A and B, simultaneously. Imagine you have a website and you want to test a new design. You show version A to half of your users and version B to the other half. By comparing how users interact with both versions, you can determine which one performs better. This method helps make data-driven decisions on which version to fully implement based on real user feedback. Stages of A/B testing. Planning. Define the goal of the test, e.g., improving click-through rates. Choose a single element to test, e.g., headline, button color. Creating variants, develop two versions, A, control, and B, variation. Ensure only the chosen element differs between versions. User segmentation. Randomly split the audience into groups, showing each group one version. Key benefits. A/B testing measures the effectiveness of application features by controlling the target audience and monitoring user behavior differences. Considerations. Complex setup. Requires a representative sample and sufficient test duration to achieve statistical significance. Validity. Results can be skewed by false positives, biased sampling, or external factors. Observability. Running multiple tests on overlapping traffic complicates monitoring and analysis, requiring tools like distributed tracing to understand metrics accurately. Shadow testing is a technique used to test a new system or version of software without affecting the current live system. Here's a simple explanation. Imagine you have a live system that users are currently using and you want to test a new system. In shadow testing, you run the new system in parallel with the live system. The new system processes the same inputs as the live system, but its outputs are not visible to users. This allows you to compare the new system's performance and behavior against the live system without impacting the user experience. It's a way to test changes in a real-world scenario safely. Here are the steps for implementing a shadow testing strategy. Set up a parallel system. Create a duplicate system, shadow, that mirrors the live system but does not affect real users. Duplicate traffic. Route a copy of real user traffic to the shadow system while keeping the original traffic flow to the live system. Compare outputs. Monitor and compare the outputs and performance of both systems to identify any discrepancies or issues. Analyze results. Use the findings to refine and optimize the shadow system. Prepare for deployment. Once confident, consider integrating the tested changes into the live system. When choosing a deployment strategy for your application, consider factors such as downtime tolerance, cost constraints, team expertise, and testing needs. Determine if you need to test new features on live traffic or specific user groups. Evaluate if your infrastructure, like microservices, is flexible enough to handle updates and if schema changes are manageable. The best deployment method will depend on your business's specific needs and technological capabilities. Always weigh the pros and cons of each approach to select the most suitable option. You can find Google's chart for that purpose. You can find the link in the description. Thanks for watching. Please make sure to like and subscribe to support my journey.